So, good morning, dear students. So, let us start with today's lecture with the topic current commutated chopper. So, yesterday we did we learned about the voltage commutated chopper, wherein we learned that the main SCR, the conducting SCR, is turned off by applying a reverse voltage through a capacitor on the main SCR. So, because the voltage is used to turn off the main SCR in case of voltage commutated chopper, so that is why it is known as voltage commutated chopper. Today, the chopper circuitry which we will discuss is current commutated chopper, and in this particular chopper circuitry, a pulse of reverse current will be used to turn off the main SCR. Okay, how this happens, that we will discuss and understand. So, circuit diagram of so the circuit diagram of a current commutated chopper is shown here. You can see this is the main SCR and this is an auxiliary SCR. So it is an SCR basically. So I forgot to put a gate terminal here. And then we have a diode 1, diode 2, then capacitor and inductor, then a freewheeling diode. So apart in this particular circuit, this one, except T1, the main SCR, all other components are basically the commutating components. Specifically this part of the circuitry, this one. This part of the circuit is the commutation circuit, because somehow these components will be used to turn off the SCR and to keep the main SCR in reverse biased mode. The load here connected is an inductive load, and that is why a freewheeling diode is connected here. So when this part of the circuit is disconnected from the supply here, so in that case this freewheeling diode comes into action, and the current which is stored in load in some form, that current is dissipated through freewheeling diode. That means the current freewheels through this diode, and that is why this diode is known as freewheeling diode. Now, so there is a resistance connected here, RC. It serves the same purpose as it served in the voltage commutated circuitry. That let us suppose that this whole part is off, means T1 is also not conducting, TA is also not conducting, TA is also not conducting, and D1 is also not conducting. So in that case, what happened? The current that will come, that will be released by this supply, will not enter to any of these paths. It will straightforward go to the capacitor through RC and this one. This is how the current will flow. So it will charge, this current will charge the capacitor with a voltage which is equal to Vs. So that means at time t is equal to 0, our assumption is that the capacitor which is used here is charged with a voltage equal to Vs plus Vs. Now you can see I have shown some directions here, direction of IT1, then direction of IC, then IFD, then load current, V0, VTA, VT1, Vs and Vc. So these directions are assumed as positive. The polarities which are indicated here for voltages and the direction of current are assumed as positive. So in case the voltage, any of the voltage reverses or any of the current reverses its direction, that would be taken as negative. So initially, so there are now similar to the voltage commutated chopper, in this particular chopper circuitry also we have certain assumptions, and these assumptions are that load current is constant, SCRs and diodes, they are assumed to be the ideal switches. Now you all know what is the meaning of ideal switch, which do not possess any resistance when during on state basically. Now the value of RC is very large, so that it behaves as an open circuit when the commutation interval is going on. Now what does it mean? It means that when the commutation process is going on, this resistance should not give any path to the current. It should behave as an open circuit. I mean, it is that large basically. Now so all the currents are and voltages are positive as marked in the circuit diagram. So the working of this particular chopper circuit is explained in 5 modes basically. The mode 1 starts from t is equal to t1 and ends at t is equal to t2. The circuit diagram of chopper in mode 1 is given here. So let us see what actually is happening here. D1 is reverse biased. D2 is also reverse biased, actually. TA is forward biased and it is conducting. T1 is also conducting. So at t is equal to 0, the capacitor is charged with voltage Vc is equal to Vs plus Vs. And that means before this mode, when t is less than t1, what actually is happening? In this case, this SCR is not conducting at all. Only T1 is conducting and the capacitor is charged with a voltage equal to Vs. Now the current is flowing in this direction. This is how the current will flow. Which current? Load current. Now if you apply KVL in this outer loop, you will find that Vs is equal to V0 as per KVL equation. So let us see the waveforms for the duration t less than t1. So here you can see the waveforms. Ig1 is the gate pulse indicating the gate pulse for the main SCR. Ij is the gate pulse for the auxiliary SCR. I0 is the load current here. It1 is the current of main SCR. Ic is the charging current or capacitor current. ID1 is the current through diode 1. IFD is the current through freewheeling diode. VC is the voltage across capacitor. VT1 is the voltage across main SCR. V0 is the output voltage. VT is the voltage across auxiliary SCR. So at t is equal to 0, T1 is turned on. The main SCR is turned on. So let us see the main SCR. So main SCR is turned on. Diode D1 is reverse biased because the cathode of diode is coming under the effect of positive voltage here. Capacitor is also positively charged. So this is positive. And this is also positive. So the auxiliary SCR is favorable for conduction, but it will not be triggered. It will not be turned on at t is equal to 0. So at t is equal to 0, or from to T1, T is equal to 0 to T1 for this duration. Thus capacitor current is 0. That means no current is flowing here. This IC is equal to 0. Right? ID1 diode current 1 is 0, IFD is 0, VC, now let us see VC, VC is plus V. This is what we are saying, that the capacitor is charged with a voltage which is equal to Vs. No current will flow through this diode, no current will flow through this diode, IFD, no current will flow here. Right, all these values are 0. Now voltage across SCR1 is 0 because we have assumed that these SCRs and diodes which are connected in circuit are ideal elements. And the voltage across load V0 is also equal to Vs as per the KVL equation. Voltage across auxiliary SCR is equal to Vsy because this auxiliary SCR, though it is under the effect of positive voltage, the anode of auxiliary SCR is under the effect of positive voltage. But until unless you trigger this SCR, it will not turn on. That is the specialty of an SCR, right? So let us say, I'm sorry, we trigger the auxiliary SCR at T is equal to T1. The auxiliary SCR is turned on at T is equal to T1. So from here the commutation process of the main SCR starts. So T1 is triggered just to bring commutation to the main SCR. This is the purpose of triggering T1. So that brings the mode 1 from T1 to T2. At T is equal to T1, T is triggered to turn off the main SCR. The capacitor current IC is given by IC is equal to Vs by omega L sine omega naught T. So let us see what is Is. For duration T1 to T2, you can see for duration T1 to T2 here, the capacitor current is sinusoidal for half cycle. It is sinusoidal. And capacitor voltage is cosine wave, kind of cosine wave for this, or it is, you can say, sinusoidal basically, right? So now you can see what will happen. You have turned on this auxiliary SCR. You have turned on the auxiliary SCR, right? Now, as soon as you trigger the auxiliary SCR, the capacitor which is charged with upper plate positive and lower plate negative will start releasing or discharging through TA and L. The capacitor current will flow in this way. From 0 to T1, means before mode 1, you can ask that why the capacitor current could not flow. The capacitor current cannot flow like this. Basically, capacitor current always tend to flow within the resonating circuit. That is why the nature of current, capacitor current, is oscillatory basically. It is a resonant current. So it will flow as soon as you turn on the auxiliary SCR, the capacitor current will flow through TA and L. Now what will happen? Just try to assume and imagine that now capacitor discharging actually through TA and L. Capacitor is discharging. Now when the capacitor will discharge, it will reach to its peak value. It will reach to its peak value. You can see capacitor is actually discharging. Now when it is discharging, the capacitor current will reach to its peak value. This will, let us say, ICP. Or this is the peak value in negative, you can say. Okay, the peak value in negative. Now why we have taken the negative direction? Negative direction is taken because the actual direction of current, positive direction, is towards the positive plate, this one. Now in this mode, in this condition, the capacitor current is flowing in this way, opposite to the direction marked as positive. So it is taken as negative. Now the capacitor keeps on discharging, so at some point of time what will happen, as the capacitor is discharging, its voltage is also reducing. So when the capacitor will have its peak value, the voltage across capacitor will be 0. That means at that point of time the capacitor C is completely discharged. Now since this current is a resonating current, so it will keep on rotating in the same direction, as because of the characteristic of capacitor L and C basically. So now the capacitor current will tends to reduce in the reverse direction, means now capacitor starts getting charged with the opposite polarity. This current keep on rotating. Now at some point of time the capacitor will charge with plus and minus. Now what will happen? At some point of time t2, the capacitor current becomes 0 and the voltage across capacitor becomes minus Vs. This becomes minus Vs. Now why minus Vs? Because the lower plate is positive and upper plate is negative, and this is opposite to that of the marked direction, reference direction. Now what will happen here? At T2, means at the end of this particular mode, TA will turn off. Why TA will turn off? Because जो यहाँ से करंट फ्लो कर रहा था TA से कैपेसिटर का, वो करंट 0 हो गया T2 पे. Now when it becomes 0, this current which was flowing through TA was its anode current, and naturally the anode current has become 0 naturally. Now when the anode current becomes 0 for an SCR, that particular SCR will turn off. So all the story is written here. Mode 1, Vc is equal to 0. Now Vc is equal to 0 when the current is peak, when the capacitor current is negative maximum. At t is equal to t2, IC tends to reverse in the auxiliary SCR. Basically आफ्टर T2, मान जब ये प्लस और माइनस हो जाएगा तो ये यहां से रिवर्स होने की कोशिश करेगा, और वो 0 भी हो गया जो पहले करंट फ्लो कर रहा था. अब क्या हुआ, ये टर्न ऑफ हो गया. दिस विल नेचुरली टर्न ऑफ द ऑक्सिलरी एसियर TA. नाउ एट T2 Vc is equal to minus Vs. आप वेव फॉर्म से भी देख सकते हो. एट T2 Vc is equal to minus Vs, right? During mode 1 there is no effect or effect on the T1. इस पूरी प्रोसेस का T1 पे कोई इफेक्ट नहीं था. मींस जो लोड करंट फ्लो कर रहा था वो तो ऑटोमेटिकली फ्लो कर ही रहा था. ये जो रेजोनेटिंग करंट है, बेसिकली हमने TA को ऑन किया, और TA को ऑन करके क्या मिला हमें, कैपेसिटर जो है वो रिवर्स चार्ज हुआ. एंड पर्पसफुली द कैपेसिटर इज कनेक्टेड इन सच अ वे दैट it acquires a negative voltage, so that negative voltage can be used to turn off the main SCR, right? So the load current was flowing actually as it is. So load current I naught is this one, and load voltage V naught is equal to Vs. So mode 1 में वो सब वही रहेगा. V naught is equal to Vs. I naught यानी कि जो load current है is a constant current I naught. Now the mode 2 starts. Mode 2 starts at t is equal to T2 and ends at t is equal to T3. Now you can see the mode 2 is basically a very small, it exists for very small duration. Now at the start of mode 2, the capacitor voltage starts reversing. It is reversing basically. So this is mode 2, and the capacitor current is also becoming positive. Positive means it will flow in its actual direction, जो हमने positive mark की है, right? But the main SCR current, आप देख सकते हैं जो main SCR current है, that will fall to 0. जैसे जो कैपेसिटर करंट है वो I नोट के बराबर होता है, यानी कि T2 से T3 इस मोड में, सेकेंड मोड में जो कैपेसिटर करंट है that becomes I नोट, that becomes equal to I नोट. And when it becomes equal to I naught, the IT1 becomes 0. How? Let us see. Let us see this. Now, at the end of mode 1, TA become commutated. So it is naturally commutated, it will turn off. नाउ सी कैपेसिटर इज चार्ज विद द पोलैरिटी प्लस एंड माइनस, जो हम इससे पहले डिस्कस कर रहे थे यहां पे, कि जब ये रोटेट करेगा करता रहेगा और ये क्या करेगा, कैपेसिटर को वापस से नेगेटिवली चार्ज कर देगा। तो वो चीज जो है मोड 2 में समझनी है। नाउ कैपेसिटर इज चार्ज विद लोअर प्लेट पॉजिटिव एंड अपर प्लेट नेगेटिव, this thing will turn on this particular diode, because this inductor will become positive here and this point will also become positive. Now when the inductor start releasing current, because the capacitor current is released through inductor, so inductor is releasing current basically, so it will make the anode of this diode D2 positive and it will forward bias this particular diode. Also just try to understand, this end is negative, this end is negative, so and this is an ideal element, so this whole path, so here also we have negative, so that means this diode, its cathode is negative naturally during mode 2 and anode is positive, so this diode will get forward biased. So as soon as this diode gets forward biased, it will give path to this particular current to flow through it. Now this current will flow in this direction. Which current? Capacitor current, charging current. Now see the direction of current. ये डायरेक्शन क्या है जो हमने पॉजिटिव मार्क की थी, अगर मेन सर्किट में आप देखेंगे, so the positive direction which is marked is same, so that is why the capacitor current is taken positive here. You can see the capacitor current is positive, it is positive, so it will become equal to I naught at T3, at T3 you can see, at T3 to become equal to I naught. Now if you apply KCL at this particular node, there are two currents coming to this node and one current going from this node. The current going from this node is equal to I naught. As per KCL, the current leaving the node is equal to current entering a junction. Leaving a junction is equal to current entering a junction. So entering junction is IT1 plus IC. So rearranging this equation, you get IT1 is equal to I naught plus minus IC, sorry. Right? Now what actually happened? This current will, this capacitor now will discharge in this direction. So the current will reach to a certain value. So at some point of time, which is equal to T3, this current will become I naught. So that means the value of capacitance which is used here should be chosen in such a way that the current, discharging current, should become equal to I naught at some point of time. Now just try to imagine the process, whole process, that you have IT1 flowing in this direction, you have an opposite force which is IC, which is increasing. You can see it is increasing. So when this negative force is increasing, so it is suppressing the main current, means main SCR current IT1. So at T3 the main SCR current will become 0. So that means at T3 the main SCR will turn off, because its forward current IT1 has become 0 due to the pulse of current produced by the commutating capacitor, and just because the anode current is suppressed by a negative current, so we call this chopper circuit as the current commutated chopper, because the current is used to turn off the main SCR. The whole story is written here. This will turn off T1 at T is equal to T3 by the charging current IC, hence it is known as current commutated chopper. Now let us come to mode 3. So mode 3 start at T3 and ends at T is equal to T4. So let us see the waveforms here. So this is T3, this one, and this one is T4. So mode 3 exists for this particular duration. Here, this is mode 3, right? So let us see what actually is happening. Now, at mode 3, you can see, though T1 is become reverse biased, it is turned off. But this negative voltage will turn on this SCR. It will make this SCR a forward bias. And this positive voltage is appearing because this path is completely short, assuming D to be an ideal switch. So this diode, it was connected like this, cathode on the supply side and anode on the load side, towards the load side. So this becomes positive, this becomes negative. Now, so this diode start conducting. That means the capacitor current will not become zero just because T1 is become reverse biased. The capacitor current was earlier flowing in this path. Now as soon as D1 will get forward bias, this capacitor current will start flowing through D1. So that means now the value of capacitor current will increase beyond I0, and that is shown here. That means from T3 onward, the capacitor current will reach to some peak value, positive peak value, right? At some point of time, or where the capacitor voltage will become zero. That means the same thing will happen as it was happening in mode 1. That now the capacitor was discharging earlier like this, so its voltage was also reducing with time. Now the capacitor is discharging through D1, the voltage will reduce to zero at some point of time in the middle of the interval T3, T4 and T3, means T4 minus T3 is a total interval. So somewhere in the middle of this interval, the voltage across capacitor will become zero, and the capacitor will charge with a voltage, positive voltage, with upper plate positive and lower plate negative. This is what we have taken in the main circuit. If you see, in the main circuit, if you see, the upper plate is positive, lower plate is negative. This is assumed to be positive direction, right? So you can see it in the waveforms also. It will reach to the peak value where the capacitor current becomes peak. You can see the voltage across capacitor is zero. It is zero, right? Now the voltage across capacitor will tend to reverse in the actual direction, positive direction, and it becomes some positive value, which is not equal to Vs, some positive value, which is some VBA. This one, ये Vs है, यहाँ पे ये Vs है, और you can see that this is some VBA, right? And at this point of time, the capacitor current becomes equal to I0, not zero. वो zero तब बनेगा जब कहीं अगर वो somehow suppress हो जाए. लेकिन at interval at point T4, जो capacitor current that has become I0 equal to I0. Let us see in mode, this mode. So D1, D2 both are forward by, load current flows through. Now load current will flow through Vs, Vc, L, D2 and load. अब देखो यहाँ पे क्या हुआ, अभी इस करंट की वैल्यू क्यों बढ़ी? यहाँ पे दो कारण थे. एक तो करंट, कैपेसिटर जो है वो डिस्चार्ज हो रहा था. सो कैपेसिटर, क्योंकि लॉसलेस सिस्टम हम मान के चलते हैं एलसी सर्किट को, सो कैपेसिटर का जो करंट है जब डिस्चार्ज होता है, सो वो अपनी पीक वैल्यू पे पहुंचता है जब उसके क्रॉस वोल्टेज जो है वो जीरो हो जाती है. दैट इज अ कैरेक्टरिस्टिक, राइट? बट यहाँ पे एक और चीज हो रही है, दैट इज कि आपका जो लोड करंट है वो भी कहीं ना कहीं उसको इंक्रीज करने में हेल्प कर रहा है. जब ये करंट, लोड करंट इधर आएगा तो यहां से आईसी और आई नोट दोनों एक तरह से ऐड हो जाते हैं, और ये करंट यहां से फ्लो करेगा D2. जब इस जंक्शन पे पहुंचेगा, अकॉर्डिंग टू द रेजिस्टेंस ऑफ द लोड, जस्ट रिमेंबर, अकॉर्डिंग टू द रेजिस्टेंस ऑफ द लोड, ओनली लोड करंट विल डाइवर्ट हियर. रेस्ट ऑफ द करंट कहां चला गया? D1 से. तो ID1 क्या हुआ? IC माइनस आई नोट, यहां पे आ गया. ठीक है, तो बाकी सारी कहानी जो है इट इज रिटन इन द नोट्स. आप ये जो मैंने अभी बोला, ठीक है. तो पीक वैल्यू जो है बेसिकली इट इज इक्वल टू Vs बाय V नोट L. पीक वैल्यू यही पीक वैल्यू है. दिस वन इज अ पीक वैल्यू, एंड इट इज इक्वल टू, यू कैन सी IC इज इक्वल टू ICM. आप इसको ऐसे भी लिख सकते हो, आई सी इज इक्वल टू आई सी एम साइन ओमेगा नोट टी। सो आईसीएम और आईसीपी भी लिख सकते हो, नोटेशन है कैपिटल आईसीपी। सो आईसीपी इज इक्वल टू वीएस बाय ओमेगा नोट एल, राइट। अब आते हैं कहानी मोड 4 पे। अब मोड 4 कहां से शुरू हुआ, T4 से, और कहां तक है, T5 तक है। सो लेट अस सी T4 और T5, ये है मोड 4। सो मोड 4 के लिए जो आईसी है वो आई नोट के बराबर है, यहीं से, यानी यही करंट फ्लो कर रहा था यहां पे, ठीक है, आई नोट फ्लो कर रहा था। नाउ लेट अस सी मोड 4 जब होगा, सो D1 रिवर्स बायस हो गया, कैसे हुआ ये भी समझेंगे। D1 तो रिवर्स बायस था ही, ऑफ है, TA भी ऑक्सिलरी रिवर्स बायस है। D2 रिवर्स बायस नहीं हुआ। Now what happened, just see, ID1 is equal to IC minus I naught. Just remember this equation now. Now at T is equal to T4, now let us see at T is equal to T4 what happened. At T is equal to T4, ये duration, ये वाला duration, इसको पकड़ लो। At T is equal to T4, this duration IC has become equal to I naught. Now let us put this value in this equation. IC is equal to I naught, so I naught minus I naught is 0. ID1 is 0. That means the anode current, the forward current of diode 1 is 0. That means it will turn off. So hence diode 1 is turned off. It is turned off, right? So at T is equal to T4, a constant. Now what happened? अभी इधर तो करंट कुछ नहीं फ्लो कर रहा है. Now you can see the load current will flow, keep on flowing in this direction. This is how it will flow. This is the direction of load current. This is totally network analysis, nothing else, right? So this is how the load current will keep on flowing. Now the summary is mentioned here at T is equal to T4, VC is equal to VT1, we see VC is equal to VT1, where T is equal to T4. So this voltage VBA, which is equal to VT1, means the voltage which is appearing across the main SCR. The voltage of capacitor is actually appearing across the main SCR, right? So V naught is equal to, if you apply KVL here, if you apply KVL in this path, you will get V naught is equal to Vs minus Vc. At T is equal to T5, let us see what happens at T is equal to T5. Here, Vc has become equal to Vs. It is shown. Vc becomes equal to Vs. Now because Vc becomes equal to Vs, so V naught becomes equal to 0. So let us see. So V naught has become equal to, T5 पे देख लीजिए यहाँ पे, V naught has become equal to 0. ये 0 हो गया. जैसे लीनियरली देखो, कैपेसिटर जो है लीनियरली चार्ज हो रहा है और आपका V naught भी लीनियरली 0 हुई. अगर आप इसे गौर से देखें, T4 से T5 तक आपका कैपेसिटर लीनियर, वोल्टेज जो कैपेसिटर लीनियरली इंक्रीज हुई है और V naught जो है लीनियरली डिक्रीज हुई है, बिकॉज ऑफ द KVL equation, this KVL equation, right? So here ends the mode 4. So let us come to mode 5, which is from T5 to T6. Now in this particular mode, the capacitor voltage basically it increases to a certain value. You can see from T5 to T6, the capacitor voltage will increase. That means the capacitor is basically overcharged. Capacitor is basically overcharged here. ये overcharge हो जाएगा, ठीक है, और इसकी जो वोल्टेज है वो Vs से ज्यादा हो जाएगी. जब इसकी वोल्टेज Vs से ज्यादा हो गई, तो ये क्या करेगा, ये फ्री व्हीलिंग डायोड को टर्न ऑन कर देगा. ये वोल्टेज फ्री व्हीलिंग डायोड को टर्न ऑन कर देगी. जब ये चीज होगा तो फ्री व्हीलिंग डायोड आपका जैसे टर्न ऑन होगा, ये फॉरवर्ड बायस होगा, तो ये पूरा यहां से यहां तक शॉर्ट हो जाएगा और जो करंट लोड में कनेक्ट स्टोर्ड है दैट स्टार्ट्स फ्री व्हीलिंग थ्रू फ्री व्हीलिंग डायोड. बट साथ के साथ कैपेसिटर करंट भी जा रहा है. So that means load current is now equal to IC plus IFD. But now capacitor current will become zero. Why the capacitor current will become zero? क्योंकि आपका जो ये वोल्टेज है, अब ये कंप्लीटली जब चार्ज हो जाएगा, आपका कैपेसिटर जब कंप्लीटली चार्ज हो जाएगा, इट विल ब्लॉक इट्स करंट, it will block the current through it itself. So this current now will become zero, and eventually you have only the freewheeling current flowing in the circuitry. That means this path gets disconnected now. Only this part keeps on working in mode 5. So this is what is been written in this story. Everything is written here, right? So you can see that from T5 to T6, the freewheeling current increases. Yes, obviously it will increase because of the inductive nature of the load, and the capacitor current will fall to zero at the end of this particular mode, means at T is equal to T6. And capacitor voltage, now here your capacitor voltage is maximum charge. This is the peak value of capacitor voltage. This is VCP. This is the peak value of capacitor voltage, right? So here at T is equal to T6, the whole commutation process ends. Okay, eventually what will happen, based on the capacity of the load and the current stored in the load, the freewheeling current will keep on flowing a constant value, and at some point of time T, the freewheeling diode, means the current will completely dissipate, and this current will also become equal to zero. So at this instant where the freewheeling current becomes zero, we turn on the main SCR once again, and hence this whole cycle will repeat, right? This whole cycle will repeat. Okay, now the important thing which we need to understand is that this whole process is happening just because of the LC circuit, the resonating circuit. And second thing which you can know about this circuit is that this circuit was developed by Hitachi Electrical Corporation, Japan. और सबसे ज्यादा जो ट्रैक्शन कार्स में इसको यूज किया जाता है, ट्रैक्शन कार्स में, ठीक है। ये जो चॉपर सर्किट है, जो कल भी हमने पढ़ा और जो आज भी हम पढ़ रहे हैं, ये चॉपर सर्किट जो बेसिकली है, ये रिसर्च के थ्रू आए हैं। दिस इज टोटली अ रिसर्च बेसिकली, ओके। उसके बाद ये डेवलप हुए हैं, फाइन। सो इट हैज सर्टेन एडवांटेजेस, रिलायबल कम्यूटेशन होता है, लेकिन उसके लिए कंडीशन है। कंडीशन क्या है कि जो लोड करंट आई नोट है, इट शुड बी लेस देन द पीक चार्जिंग करंट ICP. Capacitor is always charged with the correct polarity, means wherever required, the capacitor charges itself with the required polarity, whether it is with plus Vs or minus Vs or greater than Vs, because the capacitor is connected in such a way that it will charge itself with the right polarity, right? And auxiliary SCR is naturally commutated, it naturally turns off, so we don't need any other circuitry to turn off the auxiliary SCR, right? Now design consideration, now because the whole process, the whole commutation depends upon the value of L and C. So the value of L and C should be such that we achieve a reliable commutation of the circuitry, right? So to have the reliable commutation of the circuitry, the value of L should be equal to Vs into Tc divided by X I naught bracket pi minus 2 sine inverse 1 by X and bracket close, where X is the ratio of the peak charging current to the load current, constant load current. So X is a constant, basically constant factor, right? Similarly, the value of C depends upon the load current and the circuit turn of time, TC, circuit turn of time, and supply voltage. So these three, and of course on the peak current also ICP, because it depends upon X. So peak current पे भी वो depend करता है, right? So similarly, I have written here also that for reliable commutation, there are two conditions. One thing that the peak current should be. So let us continue. So basically the two conditions which are required for the reliable commutation are that the peak charging current should be greater than the load current, and the circuit turn off time should be greater than the commutation time of the main SCR. These two are different things basically. These two are different things. Circuit commutation time and capacitor SCR commutation time is different. Okay, so circuit commutation time should be greater than the SCR commutation time. So let us say that TC, circuit commutation time, is equal to TQ plus delta T, where TQ is the main SCR turn of time. So that means the circuit turn of time is slightly greater than the SCR turn of time, right? Now this value, this peak value, this one of the capacitor voltage is given by VCP. VCP is equal to voltage at T5. So let us see the voltage at T5. What is the voltage at T5? The voltage at T5 is equal to Vs, right? Plus the voltage rise due to the energy transferred from L to C during T6 minus T5. So let us see during T6 minus, this is T6 minus T5, this one. So voltage at T5 plus this one. So this gives you the peak value. So if you see, it is like this. So this is value of Vs here, and this is some VCP, right? So now this voltage is because of the energy transferred by the inductor to the capacitor. Since it is a resonating circuit, so they would assist each other, and that is why the value of capacitor voltage increases to a peak value which is equal to Vs plus I naught under root L by C. So this is, sorry, this is the amount of the energy or the voltage transferred or gained by the capacitor because of the inductor, right? Now similarly we can find out the total commutation interval. So you can see that the commutation process starts at T is equal to T1 and ends at T is equal to T6. So that means the total turn of time of the circuit is T6 minus T1. This is the total turn of time. So this can be calculated through a derivation. So after deriving the equation, we get an equation which is given here. This one. Similarly, we can find out the turn of time of the main SCR. So the main SCR is turned off where? Let us see. Here. कहाँ पे turn off होता है main SCR? यहाँ पे T3 पे और T4. Okay. So T3 पे होता है T4 minus T3. So this gives me this one. Similarly, auxiliary SCR भी कहाँ पे turn off होता है? T2 पे. ITA नहीं बनाया, चलिए कोई बात नहीं. So auxiliary SCR turn off होता है यहाँ पे T3 पॉइंट पे, राइट? सो बेसिकली उसको भी हम कैलकुलेट कर सकते हैं, and the equation is given here, right? So this was all about the lecture current commutated chopper, right? And here we complete our unit number 4 basically. So now we are only left with the numerical practices. So in tomorrow's lecture and day after tomorrow, in both lectures, we would be doing the numerical practices. So as of now, I am postponing the quiz test that I would take in next week if possible. Okay. So if you have any question, you can ask me.
Nice, sir.
Any question, बच्चे?
No, sir.
Chalo then, thank you so much.
Thank you, sir.